My name's Greg Farley. Thank you for coming to this morning's presentation. This is Chesapeake College's part of the session this morning, and we won the Green Genome Award from the Seed Center and the American Association of Community Colleges. Our Green Genome Award celebrates the partnerships that we have built in pursuit of sustainability on our Y Mills, Maryland campus. Dr. Viniar is in the audience this morning and can field questions from you folks after the talk. But what I'd like to do is to introduce you to several of our partners and have them talk about the projects that are going on our campus in pursuit of both sort of power sustainability and sort of grid issues, as well as some watershed work that we have going on. So thanks for joining us this morning. I'd like to begin by introducing my first two guests, both of whom represent a battery firm that's partnered with the college to bring some battery power associated with our solar project and a potential microgrid project to the campus. To my immediate left is Drew Adams, Head of Strategy and Partnerships for AF Mensa, a battery vendor from New Jersey. And to his left is Ajay Mensa, who is the CEO of the company.
Thanks for having us.
Well, thank you both for being here this afternoon. So what is storage technology, and what are we bringing to campus, and why are we doing that?
Storage technology essentially is any technology out there that's used to store electricity for usage at a later time. The joke is that there are probably as many galaxies and stars in the universe as storage material. They range from the classic hydro pump systems that we have, to lithium-ion based technologies, or what we call solid-state based technologies. The most prevalent these days are lithium-ion based battery storage.
Last summer, Chesapeake College turned on a 2 megawatt solar array, and we now, on most sunny days, make all the power that the campus needs. Our utility company developed a sort of project plan for us that involves some very cutting-edge technology. Some of it involves being able to curtail energy coming off of the solar array, and another part of it involves being able to store some of that energy. Drew, as the head of partnerships, how did we get here?
It was a long and a short road, in a way. We've been working with Pepco, who is the owner of Delmarva Power and Light, local utility here in Y Mills. Through that relationship, they introduced us to this project and brought us in on an opportunity to propose a microgrid here at the college through the Maryland Energy Administration Game Changer Grant, to which we submitted in partnership with the college, and Pepco and Delmarva was the prime on that.
So, Ajay, what does your firm hope to get from this partnership? I know for our part from the college, we're very excited about being able to teach the region about what is necessary to move more renewable energy onto our grid.
Well, the first thing that we're hoping to get out of it is to demonstrate exactly what you just mentioned. We have seen throughout the world, actually, that renewable energy to be integrated into the grid requires a lot of battery storage to allow more solar and more wind to move forward. So definitely the first thing we're hoping to get is to demonstrate the ability of our technology to help move renewable energy forward. Second, that we can help foster education for the next generation of workers out there for clean tech. Our industry is severely underserved with technical talent. Gives us an opportunity to work with the college to train students who will later on go and work in exciting fields of clean tech. So we're not just talking about design engineering jobs out there. So it starts at a conceptual stage, where we get a lot of design engineers involved, but then we have to move it to the manufacturing floor, test it, deploy it, and maintain it. And so we believe community colleges are the right place for us to develop the type of partnership that will provide us with that workforce.
In terms of future partnerships, in terms of future development, Drew, what's the value of this project to other institutions and other companies like yours?
Sure. I think one of the big objectives of this project is to use it as a model that can be replicated to other areas in the state of Maryland, across the East Coast, and across the nation. And so you really need a leadership role like the college to step in and work through the kind of beginning stages of a project. So a lot of times, first of its kind project, you reveal issues that maybe you didn't foresee happening, but you also get the opportunity to structure, from all the way from finance and the technology, a nice structured package that you can then replicate to other projects.
So one of the things that we've done with sustainability here is we've made sure that it meets both an environmental bottom line, which is in keeping with our mission statement, and also a financial bottom line, so that we are contributing to the overall fiscal health of the institution. Ajay, can you talk for a bit about how does this all pencil out? What does this mean in terms of dollars and cents, both for your firm, for the utility, and for the college as a whole?
First of all, I want to point out to the audience that you can be sustainable and still meet your goals for your bottom line using battery storage and using solar, not just to meet your electricity need, but also to provide services to the power company. The electricity produced by the solar gets sold to the college right away at a rate that is less expensive. When it comes to the battery storage, the electric utility in this area has a lot of needs, a lot of reliability needs that can be met by the battery storage more efficiently. We enter into an agreement with the power company to make the battery storage available, to provide those services. We get power outages less than 1% of the time, but when we get them, they are extremely disruptive. But 99% of the time, the battery, we monetize it by providing a lot of reliability services to the power company. And for that 1% or less of the time when there's a power outage, then the battery switches into a resiliency mode, working with the solar to continue providing power, to the campus.
One of the things that we hope to get from this project is a little bit of microgrid technology. As an end user, my understanding is that what that should allow us to do is to meet some resiliency goals, to perhaps keep on a building or two as a shelter or as an emergency hard point for times when the rest of the regular grid is interrupted. Can either of you describe for our viewers what a microgrid is and how we implement that at a campus scale?
Sure. So in our industry, that's a term that gets thrown around quite a bit. A microgrid is a small version of the electric grid. So it essentially involves some sort of power generation system, having some sort of load that can use the power being produced, and in between a set of infrastructure that moves the power from the generation source to the load, and that manages that power. In the context of this campus, what it means is that when there is a power outage throughout the grid, we have controls and switches that will isolate the campus from the rest of the grid. And in doing so, the campus essentially becomes an island, right, electrically speaking. And so there we have the microgrid.
I've invited the operations director from Midshore Riverkeepers. This is Kristen Junkin, who's been my partner in crime on a lot of watershed projects, and I'm delighted to have you here. Thank you so much for helping us do all of what you've done, and thank you for being here this afternoon as well.
Well, thank you for having me.
One of the first things I'd like to help the audience understand is, how did this partnership come to be in the first place?
Okay, well, a little background on Midshore Riverkeepers. So we're a nonprofit in Easton, Maryland, and our mission is the restoration and protection of the rivers that are in the midsection of the Delmarva Peninsula, right here on the eastern shore of Maryland, where Chesapeake College is located. And so about 3 years ago, we did an assessment of one of the most beautiful rivers here in our area, the Wye River. It's a gorgeous river, but it's also polluted from nitrogen and sediments. And part of that assessment was to look for opportunities for areas in the land, in this watershed, this river, where there might be places where we could do stormwater management projects and restoration projects that would improve water quality, because that's our mission. It's all about water quality. Chesapeake College was a logical place to begin the discussion because, as you mentioned, the campus sits on a really ecologically sensitive parcel of land, and it's right at the headwaters of the Wye River. And the stream that's on campus drains almost that 120 acres through the campus and right into a stream which runs right into the river. So we took a look at the campus and found that there were a number of areas where we could do projects that would improve water quality. When we approached the college, we were really excited to recognize that we had a willing partner, an organization, a landowner that was excited to work with us, because that's not always the case. And we need that in order to be successful at our mission. We have to have cooperating landowners. So what we did was we sort of came up with the college's collaboration, we came up with a master plan, sort of a wish list of a whole group of projects that could be done on the campus. And they included wetland restoration, planting buffers, tree buffers, a stream restoration project, and a whole group of treatment areas where we would pond stormwater and let organic material and natural vegetation have time to take up the nitrogen and let the sediments settle before all that water runs into the college's drainage system.
One of our plans is to bring education into that process so that people can actually see it happen. They can see the construction from the beginning to the end, learn about how it's done, and that not only is traditional students but also workforce development and continuing education for engineers and for heavy equipment operators and firms that would design and install these sorts of structures. Mm-hmm. Once they're completed, we'll have an unmatched set of structures on the campus that we can then use to enhance not only our own programming in agriculture and in environmental sciences and landscape architecture, but we can also offer those opportunities out to the service counties, and the K through 12 students are more than welcome to visit us. Other organizations like Master Gardeners are more than welcome to come through the campus as well. So this becomes a showcase for education that has a lot of different endpoints.
I think the whole community recognizes the value of what we're trying to do.
I think that's been one of the lessons for us from all of the partnerships we've tried to build, is that we start with a limited set of goals and we start with some very concrete ideas. And as ideas grow and as they expand, we find that they have multiple synergistic benefits for the campus. And so that's been a sort of unintended but very positive set of outcomes for us, I think, from all of the partnerships we've tried to build.